consider a rough incline and a block placed on the surface of that rough incline. The friction between the block and the incline is sufficient such that the block does not slide on the surface. We will gradually increase the angle of inclination, and with that we will see that the body will start toppling. To understand toppling, we will have to know equilibrium. We will have to know the conditions for equilibrium of the body. There are two types of equilibrium, all of you know, translational equilibrium and rotational equilibrium. In the first drawing, this block is both in translational equilibrium and rotational equilibrium. The condition for translational equilibrium, summation F equal to 0, that means resultant of all the forces acting on the body is 0. So the forces that are acting on the block are mg, normal force, and frictional force. Since the body is in translational equilibrium, it is not going down the incline. That means the resultant of mg, ff and n is 0. Now what about the rotational equilibrium? Condition for rotational equilibrium is that the algebraic sum of the moments of all the forces acting on the body taken about any point should be 0. So here we are considering the moments of these three forces mg, n and fa about this point. Okay, why about this point? Because this point is of our specific interest, because when the body will topple, it will do that about the point P. So that's why we are considering torque about the point P. Since force of friction is passing through point P, its torque about the point P is 0, and this force mg is not passing through the point P. Its torque means sense of rotation for this force about the point P is anticlockwise, while the sense of rotation for the force, for the normal force about the same point is clockwise. These two torques about the point P are exactly cancelling each other. That's why the body or the block does not topple. It is not toppling in this situation. Now we will increase the angle of inclination further. We have increased the angle of inclination and we have reached a position, reached a state when the block is on the verge of toppling. What happens in this state? You can see that the position of the body is such, since it is on the verge of toppling, the rear end of the body has gone up, it has been detached from the surface, and mg, which is acting through the center of mass of the body, is just passing through the point P. Means line of action of mg is passing through the point of contact, and since the block is touching the incline only at the point P, normal force also passes through the point P. So about the point P, torque of N is 0, torque of mg is 0, and torque of force of friction is also 0. Okay, so the net torque about P is 0, summation tau P equal to 0. Reason is all the forces acting on the body are passing through the point about which we are calculating the torque. So the body is still in rotational equilibrium, but it is on the verge of losing its rotational equilibrium. Body is still in transitional equilibrium because frictional force just gets balanced by the component of mg. Okay, so the net force acting on the block, that means the resultant of mg, an and ff is still 0. Okay, that means the body is in transitional equilibrium. Since taught about the point P is 0, the body is also in rotational equilibrium. Now we will consider this situation. In this situation, the body, the angle of inclination is such that the line of action of mg, which is passing through the center of mass, has gone on the right of P. As a result, mg now exerts. Mg is now exerting a torque whose sense of rotation is clockwise, and the other force, normal force, other forces, normal force and frictional force, have 0 torque about the point P because of same reason that normal force is passing through P and force of friction is passing through P. So the point is, there is no torque available to counter the torque of mg about the point P. So that means the net torque acting on the block about the point P in this situation is not equal to 0. It is not 0. So under the action of the torque of mg about P, the body will rotate clockwise, which in other words is called toppling. So the gist, as long as the body is in rotational equilibrium, torque of mg about P gets exactly balanced by the torque of M about the same point. As a result, net torque about the point P is 0. In the second step, the body is on the verge of toppling. What is happening in this state? In this state, the net torque about the point P has become 0 because all the three forces have their lines of action passing through the point P. So the net torque is 0, and that means the body is still in rotational equilibrium. In the third drawing, the tilt is little more and the center of mass has gone to the right of a vertical line through P, and mg exerts a torque about P and whose sense of rotation is clockwise, and we find that other two forces N and Ff have their lines of action passing through the point P. As a result, N and Ff, they do not exert any restoring torque, any torque, restoring or non-restoring, they do not exert, they fail to exert any torque about the point P. That means the torque of mg about the point P gets a free hand and it topples, means it rotates the body. I'll now give you an exercise to illustrate this discussion. You will solve this problem to test your understanding on the concept of toppling. This is an incline, sufficiently rough. It is sufficiently rough. Angle of inclination is theta. On this incline, we have placed a block, a cuboid block. Length of this side, this edge is 6 centimeter. Length of this edge, it is cuboid, is 8 centimeter. Question is, for what angle theta, for what value of angle theta, body will start toppling? For what value of theta the cuboid will start toppling? This is the question. Answer is 37 degree. Okay, so you will solve, you will apply the concept that you have learned, and then you will check your understanding by getting the answer 37.